Let's walk through the Fitcore use case, covering the business problem, the objective, and the solution. Fitcore Incorporated is a sports brand taking over Aquafit Incorporated to expand its product range. Both brands already have customer bases, and there may be some common customers. Fitcore exports customer data as files, while Aquafit keeps customer data in a database, so we need a single, trusted, de-duplicated customer master that business users can manage through a UI application. The objective of this use case is to increase confidence in the platform by using one realistic scenario to exercise as many components as possible across the data integration layer, backend, front-end and shared modules, and to turn that into a reference pattern for future projects. To achieve this, data from both Fitcore files in the Aquafit database is pulled into SchemaWeaver pipelines. These pipelines ingest the data, validate it at source level, apply business rules, transform and standardize key attributes, and then run match and merge logic so overlapping customers are identified and unified. The output of this flow is a clean customer master schema, effectively the golden record for each customer, which is then exposed through generated endpoints and consumed by a generated UI. The same setup also enables reporting on top of the mastered customer data and provides a governed way for users to work with the unified customer master. Topics covered in this walkthrough are data sources, backend setup and target schema generation, data pipelines to move data from source to target with ETL components, generated backend services for the UI to consume, UI setup and generation, shared modules such as rules, users, workflows and reporting, and finally export and import along with AI Assist to enable quick new setups using this implementation as a reference. Let's cover the setup of data sources, namely Fitcore and Aquafit. First, we define the Fitcore file data source with details of object schema and file details. Here is the object schema in which the data would be captured from file. Using data generation component, we generate the CSV file which we stored as zipped file. Here is the file content generated. It is all customer details flattened in one single file. We have similar setup for Aquafit, which is database-based source. Customer object schema. Data generation which writes into DB. An output is generated in DB tables. Let's look at backend, target schema generation. Let's look at the domain model for the customer master. Customer is the main object, with several dependent objects around it. Company address for billing, shipping and headquarter addresses, in a one-to-many relationship. Company profile for additional company details, as a one-to-one relationship. Company contact channel for ways to reach the company, one-to-many. Company generic attribute for other key value style attributes, one-to-many. Company contact for roles like CEO and sales contacts, one-to-many. The model is sourced by both Aquafit and Fitcore, and uses business data types such as name and address rather than just primitive types, keeping it closer to real business semantics. Here are some of the business data types we've used from the address, organization and person categories. Each data type comes with built-in constraints, UI widget mappings and business entity mappings, which together help with standardization, validation, test data generation and consistent representation on the UI. Here are some of the enumerated data types we used in the domain model. On clicking of Generate button, backend code is generated. Here is quick walkthrough of generated code. You can see the various layers generated in the backend code: controller, service, repository, model with all relationships, data transfer objects, and enumerated data types. On start of server, the table structure is automatically created from the domain model. The object schemas for pre-stage, stage and main levels for the objects defined in domain model are automatically derived. This lets us move data smoothly from source to target via these intermediate stages without redefining schemas at each step. Let's now look at the data pipelines, which are built by orchestrating routes. We'll start with the Fitcore data pipeline that reads the data from file, takes a snapshot into a landing area, then validates each record against the source object schema. Only the valid records are allowed to move forward and get mapped into the pre-stage structure of domain objects. You can have a quick look at snapshot and pre-stage collections in MongoDB. A Python DAG file is generated directly from the orchestration defined in the data pipeline from UI, and this DAG can then be deployed and run on the Airflow container for scheduled pipeline execution. Similar to Fitcore data pipeline, we have 3 data pipelines, one per DB table for Aquafit, each reading data from source, taking snapshot, validating against the source, and then mapping the pre-stage object from validated source data. At this stage, we have the Aquafit and Fitcore data captured in pre-stage objects. In this data pipeline flow, data in 6 pre-stage objects are first standardized, transformed, and validated again. There is a match and merge process run, after which the deduplicated records are moved to stage tables and then to main tables. Let's have a quick look at the sum of the Fitcore routes orchestrated inside the data pipelines. We start with route that reads file and takes snapshot with data profiling and infer components. Next, route reads data from snapshot and validates against the object schema's constraints and finding duplicate records. All valid records are kept in validated snapshot. Next, route shows how different address types are mapped and then moved into pre-stage by taking union of 3 different address types, namely shipping, billing, and HQ. Next, route shows how we invoke transformation rules to derive the few columns using existing columns in company profile pre-stage object. Next, route shows how we move pre-stage data in Mongo to stage data in Postgres by remapping. Next, route shows configuration for match and merge, where we select fuzzy match on certain attributes of domain object from the selected domain model and apply trust setting for source systems Fitcore and Aquafit. Next, route shows movement of data from stage to main, which is done via API call on the generated backend application. Once all data pipelines are run, we have data in staged and main table inside Fitcore DB schema and cross-reference table maintained for mapping each record with the source it came from. When we generate a backend application with no custom endpoints, the platform automatically creates full CRUD APIs plus a generic search endpoint. For custom endpoints, one option is to use Springs-derived query methods. We simply define the method name in the UI, and the platform generates the repository method and exposes it via servicing controller. In this case, the method name is configured to search a company by name, ignoring case. Another way to define a custom endpoint is by using the query builder to create an SQL query and then invoking it from custom queries. This generates a native SQL query in the repository and exposes it via the service and controller layers. In this configuration, we simply select the pre-built custom query to search customers by organization type. The third and last way to create a custom endpoint is by defining a camel route using drag and drop, and then invoking it from the camel endpoint section. In this approach, the endpoint logic lives in the data integration layer, but it is wrapped by the backend so that all endpoints are still exposed consistently through the backend controllers. All the backend services are listed under the endpoint section, where you can see their details and test them directly. Here we're testing the find all customers endpoint, and it returns a JSON response similar to how you would test an API in Postman. Similarly, we test custom endpoint find all customers by passing organization type as input, and you can check the response. Now we have all backend services ready to be consumed on UI as discussed in the next section. In this section, we would quickly have a look at generated UI using backend services and then have a look how we configured and generated. On the left navigation bar, you can see various modules like customer management, workflow, user management, domain group, and notification setup. The customer management is the user-defined module. Others are simply included as predefined modules, which can be included as it is. Let's first have a look at various page definitions under customer management. The Manage Customer page allows you to view, edit, add, and delete customer data pulled by using the generated backend services. The service is plugged in the page definition for all possible actions. The Manage Customer nested page allows you to view, edit, add and delete customer data as well as the child objects. This is configured by plugging in the endpoints for main and all child objects as seen in the page definition. Let's quickly go through some other pages like Customer Search, Dashboard, Data Profiling, Charts, and Domain Model. In shared modules, let's start with Report Data Source configuration where we use generated endpoint and SQL queries as data sources. On report generation, the report is generated as shown. Let's quickly go through the configuration of workflow, rules and user management. Let's demo the Export All functionality, which export all configurations to selected folder. Similar to Export, we have Import, which would pull all config files from a folder and setup. Let's demo AI Assist functionality for generating object schema based on text input. It uses existing Fitcore customer schema as reference. The response from AI is imported directly. What do we gain from the Fitcore use case implementation? First, an end-to-end solution to a real customer data problem, achieved with no coding, using pure configuration. Second, we leveraged nearly 80% of the platform's components, proving the depth and completeness of the solution. And finally, we create a reusable reference setup, a blueprint that future projects can clone, adapt, and scale with confidence. Thank you for your time. We'd love to hear your feedback and thoughts in the comments.